Welcome back to the Deep Dive. Today we're taking a closer look at a very specific piece of hardware, the NTI E-ACLM-P12-V2 AC power monitor. And our mission here is to kind of shift how we see this device. It's not just a simple meter. We want to understand it as a proactive safeguard for your most critical equipment.
Exactly. It's about being proactive. And that's what enterprises and data centers really need right now. Power disturbances are, frankly, one of the biggest threats to uptime.
Other than security threats, you mean?
Right. And this device, it operates as the eyes and ears, the power quality sensor for the ENVIROMUX monitoring systems.
Okay, so let's dig into that. What are the baseline things it's actually looking at? We see it tracks the usual suspects: AC voltage, frequency, power, and current. And it's got a pretty wide operational range.
Fundamentals, yeah. They have to be there.
But the setup is interesting. It has two of those standard IEC C14 inlets, so you can put it right in line with two separate power paths.
Right, doubling your visibility. But, while those basics are necessary, the real intelligence, the aha moment, is what it tracks beyond that.
The events.
The events. It's actively logging the three big power villains we all dread: sags, swells, and spikes. It's not just measuring power use, it's counting every single attack on the line.
And it does that with some real precision. For sags and swells, those are the dips and surges, it tracks them if they last anywhere from 0.1 seconds up to a full minute.
So it's catching both the fast glitches and the longer drawn-out problems.
Exactly. And for spikes, those really sharp, destructive hits, the detection is actually user-selectable.
Which is a critical feature.
Right. You can set it to catch peaks greater than 50V, 250V, 500V, or even a massive 1kV.
And that selectable threshold is key. It lets you tune the sensor perfectly for the equipment it's protecting. You're not getting false alarms from, minor line noise. When it goes off, you know it's a real threat.
Okay, so if we can trust those numbers, and the accuracy is pretty tight, around plus or minus 1% for voltage and frequency, the next question is obvious. What happens when it finds something? That's where the relay part of the name comes in, right?
That is the absolute core of this device. The relay is what moves it from just being a tattletale to being a bodyguard. It's what makes it an active defender.
So it's not just reporting.
No, it's hardening the system. You can configure it for, say, a threshold reboot. Imagine a catastrophic sag starts. Instead of letting that unstable power corrupt data or fry a component,
The relay just clicks.
the relay engages and forces a clean, controlled restart. It takes corrective action on its own instantly.
So it monitors reports and then executes its own defense. I like that. So where can we place this defender? How does it talk back to base?
It uses the RS-485 protocol, which is a really robust standard for industrial settings. It's known for long-distance reliability.
And how long are we talking?
With a standard SEAT cable, you can place it up to 1,000 feet, or about 305 meters away from the main ENVIROMUX unit, which is already pretty far.
That's a good distance.
But this is where it gets really interesting for large-scale operations. It's also compatible with a fiber converter.
Oh, okay.
The EFSC fiber converter. And with that, you can push the sensor location out to an incredible 1.2 miles. That's 2 kilometers.
2 kilometers. Wow, that completely changes the game for where you can deploy this kind of active protection. So to kind of sum up this deep dive, the NTI E-ACLM-P12-V2 isn't just some passive meter giving you a history report. It's an active defender, constantly measuring power quality and ready to use its relay to stop a problem before it becomes a disaster.
Precisely. And that brings up a final thought, especially with that long distance capability you mentioned, that 1.2 mile range. It makes you think, right? So for you listening, what are the most remote or challenging places where this kind of continuous, proactive, and autonomous power protection moves from being just a nice to have to an absolute mission critical essential? Think oil rigs, remote communication sites, sprawling solar farms, something to mull over.